this unit, we are studying about the heat. What is the functions behind and what are the subject totals of the topics we have to study in this topic, right? The first one is which is the heat. Let's talk about the content of the heat. First one, nature, measurement, transfer of the heat, then after effect of the heat on the matter, relative humidity and specific heat, temperature scales, regulations of the body temperature, use of heat for sterilization, application heat principle in the nursing. See, this is important principle in nursing. Why should we study in this topic about the heat in the nursing course, right? In a post basic. So, nursing related of heat, what is the purpose? You have to study it in biophysics, means mechanical plus biological purpose. What are the mechanical and biological purpose? We have to study it about the heat. These all are the content behind of the heat. Let's talk about first one, nature of the heat. How many type of the heat and their nature? Let's talk about which is heat. Heat which is caused one type of the energy, right? The energy that is transferred from one body to another as the result of difference in a temperature. If two bodies at the different temperature are brought together, energy is transferred, heat flow from the hotter body to the colder body. Means what gives the example related to our body's temperature? It is transferred by heater to the cooler and cooler to the heater as according to the nature of the body and the nature of the heat. Next one, heat which is connected with the motion. It is total kinetic energy of the molecules or atom which making up a system. Means which is connected, heat which is connected with the motions. What are the motions? Motions means ki transfer. Which are the motions? Which are kinetic, means ki a calculated energy which is transferred, which is called as the kinetic energy. Okay. Then of the molecules, what the type of the molecules which are transferred by the heat in the motions? Cooler to the heat or heat to the cooler, right? Next one. See, here one give the animated peak. Observe. This is the heat transfer. This is the warmer object. This is the cooler object. Heat high temperature to the lower temperature. This is the transferation by some energy. How to be cool down of the heat and how to be build up of the heat, which is the transformation. One heat to another, which is the cooler to the heat and heat to the cooler. Next one. A quantitative measurement of the heat thermal energy given by the temperature. Means ki quantitative means ki countable. A quantitative measurement of the heat or thermal. Heat means ki thermal. Thermal related which is in a two forms, in a cooler forms and the in a heater forms. Right. So the measurements means ki calculations, scale up. This is called as the measurement. Whatever type of the measurements which are the observed by the quantitatively factor. Temperature is the measures of the hotness, means ki temperature which is the measures by the hotness, which is determines the direction in which heat energy which is transferred for a system when it is placed in contact with the another one. Means ki which determines means identifies. Just catch up my words. It determines the direction in which heat energy is transferred from a system when it is placed in contact with the another. One energy which is connected to the another portions which is converted by the energy determines by the direction. Whatever energy portions which is going to be higher, that movement and the motions that type is higher. Are you getting my point? See, determines, identified and the direction. Which type of the directions? If we are talking about the heat, the type of the direction like a heat means ki build up of the heat, which is the energetic molecules, heat up molecules which are observed over there higher. Due to that reason, it is observed scale up measurement which is higher. Next one. Let us talk about some example behind of them. When we touch a hot cup, our finger refrigerator feeling of the warmth, it means that energy which is flowing from the cup to the fingers means our energy which is transferred by higher concentration to the lower concentration as according to the rules of the biochemistry of the diffusion. The molecular wave and the motions which are always transferred by higher to the lower concentration. The cup of the higher T means ki a hot cup, whenever we touch with the hot cup, our fingers refrigerated, which is convert into the hot factor. Means ki our finger also going to be heat, and we the time we will be feel it properly. Then after temperature, which is characterize the thermal state of a body and determines whether energy will flow from to or towards it from another body in a thermal contact. Means ki which is characterized by the thermal state of a body. Thermal related of the heat means ki cold and the heat determines, which are determined whether energy will flow from to or towards another body in a thermal contact. Another body in a thermal, like in a cool up or heat up, to contact between of them. Next one. Heat and the temperature are not same. Means ki the heat and the temperature which are not going to be similar. But what is the difference between of them? The first, heat is the total energy content of a system. Heat which is a total energy content of the system, and the temperature is a measure of this energy and decide the direction and the flow of the energy. The temperature always decided to the flow, which is always observed into the motions, like in a higher means ki flow higher to the lower concentration. Next one, how to be measure of the heat. What are the measurement? How to be scale up and identified counting quantity of the heat. The quantity of the heat can be defined as some total of the kinetic energy of all the molecules of which an object which is composed of. Means ki quantity of the heat which defined as some total of the kinetic energy, which are the kinetic energy, and of all the molecules of which an object composed of the measurement of, like thermometer. This is the measurement of the heat. Let's talk about next one. Temperature, which is related to the average kinetic energy of atom and molecule in the system. The temperature which is correlated to the average kinetic energy of the atoms and the molecules by in a system, which is related to the kinetic factor energy by the atoms and the molecules into the system. Any form of energy that increase the speed of the molecules of an object will raise the temperature of the object. Any form of energy which are increase the speed of the molecules, means ki the molecules which are higher, which is speed up, which is automatically going to be higher, the motion is automatically going to be higher, and object will raise the temperature of the object. Next one, here some bowl, water bowl which is heat up by this temperature, so which is going to be water which is going to be boiled, so which is going to be increased temperature, the molecules which are going to be boiled. Next one, see, this is the thermometer, the device that gives the quantitative measures of temperature, which is called as the thermometer, right? The scale up and the measurement of the thermometers which are gives to here, which are the quantitative measurement of the temperature called as the thermometer, which are by the thermometer. Next one, advantages of mercury as the thermometric substance. What is the participations of mercury into the thermometer, and it is gives us the specific temperature. Let's talk about them. The mercury is easily visible through to the glass? Why should we use the mercury into the thermometer? To identify the temperature, which is easily visible by the glass. It can conduct the heat rapidly, means ki which can conduct the heat by the rapidly. It does not wet the glass, means ki which does not wet the glass. Wet means ki which is not gives the moisture. It is in an aqueous form. The metal in an aqueous form, still it not gives the moisture in it. It not leaves the moisture inside of the thermometer. It does not wet the glass. It has low freezing point and high boiling point. It have the low freezing point and high boiling point. Means ki which is stable in a every worst situations, in a higher freezing, in a lower freezing, in a higher boiling factor. Obviously which is in a peak, in a potential critical factor, so it can't be any type of the activity which is observed, which is going to be most of neutral. Next one, it expands uniformly with rise in a temperature. It is not indicates as the one molecules which are releasing in a bits form, but it is going to be in a quantitative factor. If the temperature which is going to be higher, the mercury which is going to be move forward, and the freezing which is mercury going to be backward, right? So it is going to be in a quantitative factor, which is not scattered. The metal constituents itself not going to be scattered, right? This is the advantage of using mercury into measurement of the thermometer, right? Next one, transfer of the heat. How to be heat going to be transferred? The heat can be transferred from one surface to another by several ways, means ki which is transferred by one surface to the another way. Like when an object is at higher the temperature than which is surrounding, the energy which is transferred to the surrounding. Means when the object which is higher the temperature than its surrounding factor, which is the surrounding factor, and energy which is transferred to by the surrounding, the energy which are absorbed by the surrounding factors. Next one, human body uses varieties of mechanisms to transfer heat and maintain an average temperature of 98.6 degree Fahrenheit. It is gives us normal body temperature. Human body which is uses varieties of the mechanism, transfer heat and maintains an average temperature, which are average of a normal temperature which is 98.6 degree Fahrenheit. Next one, skin of whole body loses heat by conduction, convection and evaporation. Our body lose heat by the skin in a three phases, in a three ways. First one, conduction, convection and evaporation, right? Conduction, convection and evaporation. Next one, let us talk about first one, conduction. It is the transfer of heat through physical contact, means ki the heat which is transferred by in a physical contact. Like for the conductions of two surfaces must come in contact with each other, means ki two surfaces which are contact by in a physical form by the touch factor in a two ways. It is the transfer of thermal energy between neighboring the molecules which is substance due to a temperature gradient. One molecules to the another molecules, which is the transfer by the gradient. What is the gradient? A higher to the lower, lower to the higher. But most of the case which is transfer the energy by higher to the lower factor. Next one, it always takes place from a regions of higher temperature to a regions of lower temperature, means ki which is always takes place from the regions of higher temperature to a regions of the lower temperature. The conduction acted to equalize the temperature differences. Conductions which is contact with act by. Equalize means ki if energy conversions which are not equal, the concentrations gradient which are not similar at the both the side, which are temperature differences by the conductions factor. Conductions need matter. Conductions always gives some situation, some matter. It is depends on some situations. Substance conduct heat at the different rates, means ki the substance which are conduct by heat at the different rates. Next one. Metal which are good conductors and non-metals are poor conductors. Which are metals which are a good conductor and non-metals are the poor conductor. Always metals which are a good conductors to transfer any heat factor to the conductors, right? So the conductor factor important for some subject, like here we are talking about metals. Okay, next one. Applications of the conductors. What are the applications? The mercury is a good conductor of the heat, so it expands rapidly with slight increase in temperature, means ki mercury which is a good conductor of the heat. Why? Because which is stable at the higher temperature and lower freezing point, which is very stable at the higher and the lower temperature. So it is used for in a heat measurement purpose. So it expands rapidly with slight increase in a temperature. Conductors play an important part in nursing and the therapeutics. When it is necessary to release heat slowly to an external portions of the body, poor conductor which is used. Rubber is a poor conductor, means ki rubber which is not gain some temperature, which is not correlated with the rubber. Heat and the rubber which are not good conductor, because heat, if the heat which is going to be higher, rubber going to be change their situations, means ki it is change their physical state. Next one. Air is poor conductor than the rubber. Air which is poor conductor than to the rubber, because the molecular gap of the air which are very higher, so the transfer of the heat which is very unarranged or unequal. The layer of the air between a piece of equipment and the body act as an insulator to prevent heat from passing too rapidly. The layer of the air between the pieces of the equipment and the body act as an insulator to prevent the heat from passing by the rapidly, Heat application serves to relieve local pain, stiffness or etching, means ki heat applications always gives to the local pain, stiffness or etching, particularly of muscles and the joints, which is particularly depends on to the muscles and the joints. Assist in a wound healing, means ki which is assist for the wound healing. Reduce inflammation and infections. The heat which is going to be reduced by the inflammation and the infection. Make the chilly client more comfortable. Raise body temperature to help maintain the normothermia. The temperature which is going to be a thermo help to maintain our body's heat by the normothermia. Normothermia means ki thermia means ki heat which is going to be normal at our body's temperature. Promote the drainage, means ki draw the infected materials out of the wounds. Next one. Second type of the heat which is convection. The convection which is the transfer of the heat by movement of a fluid, means ki liquid or the gases, which is between areas of different temperature. means ki in a liquid or in the gaseous phase, the convection, transfer heat, movement, fluid which are different. When a fluid heated, the hotter part expand and the density of these portions of the liquid which is decreases, means ki fluid which is going to be heated, the hotter part expand and the density of these portions of the liquid which is decreases. The hotter part being lighter tends to rise and its place it taken by the colder and the heavier fluid, means ki the hotter parts which are being lighter and which tends towards rise and by the place which are taken the colder and the heavier fluid. Next one. See, here we are talking about, this is the cooling factor, sink. This is the sink. This is the hotting factor, and the hot process which is going to be increased by this temperature. Okay, next one. When the all over substance, all over materialistic of the liquid which is going to be hotter, which is going to be at some boiling point of the fluid. If we are taking as the water, so which is boiled at least 100 degree centigrade, because the water's boiling temperature which is 100 degree centigrade. Example, boiling water, radiators, hot air balloons, wind blow due to convection currents, steam inhalation and colonical irrigations transfer heat by the convection. These all are the example of the heat which promote the energy, convert the some another energy and produce some product, right? Next one, the radiation. Radiation is energy that travels in the form of the waves or the particles, means ki radiation which is the one type of the energy which are travelled by the form of the waves, which is travelled by the waves and or the particles, one particles which are going to be radiated or the heated and transferred by the other factors. See here, this is the object, the heat portion source is sun, which is going to be appear onto the earth, and some these portions which are going to be heat up. Okay, next one. Here this is the symbol of the danger, the radiation which is going to be hazard. Always radiation factor which is affected with not dangerous, which is always gives as the hazardous because its impact on our genetic situations for permanently. So due to that reason, this is the symbol of the danger specific for the radiation. Okay, next one. Evaporations. What is called as evaporation? Evaporation is the process by which a liquid turns into the gas. Means ki evaporation factor which is going to be turns into the gaseous factor, just like the rain process. This is called as the a gaseous factor. Next one. Evaporations form of the human body like metabolic heat, radiation changes with surrounding walls, conductions from or to the adjacent by the air layer, convection changes with the air, then after another evaporation heat losses due to the sweating, excessive respirations by sensible and the latent heat losses. Means ki here many parameters which are going to be take which is evaporated of the water factor from to our body. Evaporations means ki losses of the water molecules. Next one. Now effect of the heat on the matter. The freezing and the melting point. What are the freezing and the melting point? The temperature at which a liquid which is changes to solid which is called as the freezing point. What is called as the freezing point and what is called as the melting point? The heat gives a solid called as the freezing point, means ki the energetic factor which are changed by in a solid factor. The temperature at which solid changes to liquid which is called as the melting. Simple, which is very simple. Temperature at the solid changes to the liquid which is called as the melting point. This is the effect on the matter. Here we are marking of the thermometer like 100 degrees centigrade and 0 degree centigrade. This is in a Celsius. Always this the unit which is in a Celsius. The boiling of the water and the freezing point of the water observed here. Next one. Vapor, the pressure. When a liquid which is heated, its molecules leave the surface of the liquid. Means ki vapor pressure, how to be create some vapor, the pressure. So when a liquid which is heated, the molecules which is leaves the surface to the of the liquid. The pressure developed by the molecules of the liquid as it is changing to the gas is known as the vapor pressure of the liquid. Pressure which is always developed by the molecules by the liquid and which is going to be changing to a gas which is known as the vapor. The molecules factors which is change as to in a liquid into the gas, right? So this is called as the vapor and it creates some pressure. Here the evaporation, the H2O molecules which are going to be converted into the gas factor by the heat and which are evaporated by the outer side into the air, and the quantity of the liquid which is going to be less, this is called as the evaporation. This is the vapor and this is the simple water molecules. Okay, next one. Third one, boiling point. What is called as the boiling point? The boiling point of a liquid is the temperature at which vapor pressure equal to the atmospheric pressure. Means the outer atmospheric pressure and remaining gives liquid pressure which are going to be similar. This is called as the boiling point. A certain quantity of heat which is absorbed by the molecules of the liquid when it changes from a liquid to the vapor. Some type of the quantity of the heat which is absorbed by the molecules, heat which are absorbed by the molecules of the liquid when which changes from a liquid to the vapor, which changes the liquid to the vapor. Next one. Here this is the molecules which are going to be boiled by the molecules to the molecules. Next one. Heat of the fusion. So it is the number of the calories needed to produce molecules separations so that materials will pass from the solid to the liquid state at the melting point. Fusion. Types of the fusion, how to, which is produce separations so that the materials which will pass from the solid to the liquid state at the melting point. When the ice changes into water at the 0 degree centigrade, approximately 80 calories of heat are absorbed before the ice melt to from 1 gram of the water. Right, here the ice which is changes into the water, means it is liquid into the solid state from to the 0 degree centigrade. Approximately how much calories which are utilized by the 80 and melt from to the 1 gram of the water, which is the calculation over here. 1 gram of the water which are going to be freeze using only the 80 kilocalories. Right, in this state energy which is always absorbed into two ways, like which is absorbed in this way and this is released in this factor. Okay, so this is the melting, the solid factor which is going to be melted by in a liquid phase, but which is the reversible. Here the second one arrow which is going to be convert into the freezing, liquid which is going to be in a freeze. Next one, the liquid which is converted by the heat, means by the heat into the vapor process which is into the gaseous factor, right? And the condensation which is going to be come out in original state. So this is absorb and conversions, right? Next one, heat of the solidification. How to be heat which is going by the solidify. So when liquid changes into a solid, the liquid liberates the same number of the calories that is absorbed in changing from a solid to the liquid, right? So the liquid which are going to be changes into the solid, liquid, liberate means liberations, means ki wo separate, which is going to be separate from to the same number of the calories. How much calories which are used by this conversion factor, which is absorbed in changing from a solid to the liquid. Next one, water which is released by 80 calories when 1 gram of water at the 0 degree centigrade changes into the ice. Means ki water which is going to be released calories by the 80 degree centigrade, or 80 calories which are used when 1 gram of the water at the 0 degree centigrade changes into the ice. Next one, again this is the energetic factor which are absorbed and the conversions, means ki first of all this is solid, this is liquid, and the gaseous factor. Okay, next one, heat vaporization. How to be heat vaporization factor? The number of the calories needed to change 1 gram of the liquid at a particular temperature to the vapor gas at the same temperature, which is called the heat of vaporization of that substances. Means ki the number of the calories which are needed by the changes by the 1 gram of the liquid, 1 gram of the liquid at a particular temperature to vapor, particular temperature which is converted into the vaporized factor by a gaseous factor, at the same temperature, whatever temperature we are going to be applied over there, which is similar, which is called the heat of vaporizations of that substance. For water it is a 538 calorie per gram at the 100 degree. See, here this is 100 degree centigrade, there is the boiling temperature of the water. Next one, heat of the condensation. So it is the number of calories liberated when a gas condensed to from 1 gram of the liquid at a particular temperature. Means what is that? The number of the calories which are freely condensed by the gas by the 1 gram of the liquid at a particular temperature. Heat of combustion. What is called as the heat of the combustion? So it is the quantity of heat in calories given off during the combustions of 1 gram of substance. It is 1 gram of the substance which are during the combustion by the factor. Combustions means ki it is utilized, completely utilized using calories and conversion. It is measured in a kilocalorie per gram, which is measured, identified in a kilocalorie per gram, which is the unit identified, measured. Sublimations. What is called as the sublimation? So sublimation is the transitions from the solid phase to the gas phase without passing through an intermediate liquid phase. Means what is called as sublimations? So sublimations is the transitions from the solid phase to, means ki the phases of the state which are converted by the solid to the liquid, liquid to the gaseous without passing through an intermediate liquid phase, without passing through by the intermediate liquid phases. Next one, relative humidity. What is called as the relative humidity? Humidity is the amount of moisture in the air. What is called as humidity? So it is the amount of the moisture which are observed into the air. This is called as the humidity. Absolute humidity. What is called as absolute humidity? It is the amount of water vapored in a given volume of the air. Means which is the amount of the water which are vapor which is given volume of the air. Then after it can be measured in a grams of the vapor in a cubic meter of the air, means ki which is measured by in a grams of the vapor in a cubic meter of the air. It's not a good parameter for day to day reference because the volume of air changes with the temperature. What is it called? Means it is not a good parameter for the day by day, which is reference, because reference the volume of the air changes with the temperature. The volume of the air which are going to be changes with the temperature. Next one, relative humidity. It is the ratio of mass of the water vapor in a given volume of air to the mass of water vapor needed for air saturation at the same temperature. What is called as the relative humidity? So which is the ratio of the masses of the water, means ki a bunch quantitative factor of the masses of the water vapor in the given volume of air with the masses of the water and needed for the air saturations at the same temperature, which is satisfied. Saturated means satisfied by the same temperature. Next one, it is expressed as the percentage, which is expressed by the percentage. Example, if relative humidity on a given day at a given temperature which is 60%, it means that 60 units of the water vapor are present per cubic meter of the air, which saturates with 100 units of the water vapor. Means what is the example? So if relative humidity on a given day, which is gives to the day, like at the given temperature, whatever we are given to the temperature, which is 60%, which is depends by the 60%, it means that 60 units of the water vapor are present per cubic meter of the air, which saturates with the 100 units of the vapor. Next one. First one, here this figure indicated that warmer the temperature and increase the amount of water vapor that can be in the air. Means ki the warmer the temperature, which is going to be increase the amount of the water vapor that can be in the air. More water vapor in the air increase the humidity level. Whatever type of the molecules of the water which are going to be higher, it increase the humidity into the air. Then after, cooler the temperatures decrease the amount of water vapor that can be in the air. Cool the temperature, decrease amount of the water vapor that can be in the air. Less water vapor in the air, decrease the humidity level. Water level whenever going to be decreased, which is decrease the humidity level as according to the definition of the humidity. Next one. Importance of relative humidity. A high humidity which is maintained in the operation theatre as it prevents that drying of the exposed tissues. Means a high humidity which is maintained in the operation theatres as which is prevents the drying of the exposed tissue, which is prevents by the drying of the exposed by the tissue which is going to be exposed to very higher preventable factor into the humidity level which is going to be higher that time. Premature infants also require high humidity environment so that evaporation from the nasal passage can be minimized. The premature infants, premature, not a mature baby born, also requires higher humiditical environment so that evaporations from the nasal passage can be minimized. Now, the specific heat. What is called as the specific heat? The specific heat is the amount of heat required to raise the temperature of a unit masses of substance by 1 degree Celsius. The specific heat, which amount of the heat required, which is going to be raised the temperature of a unit masses of substance by 1 degree Celsius, which is degree of the Celsius. Means ki heat amount which is required raise the degree of the Celsius, which are 1 by 1 going to be less. It is the ratio of the thermal capacity of a substance to that of water at the 15 degree centigrade. Means it is the ratio of the thermal capacity of substance which of the water that at the 15 degree centigrade. This is the specific heat. We are giving some specific heat to the some substance which is conversion. Thermal capacity means a higher capacity. Specific heat of the water which is 1. The water specificity which is 1. Blood pH which is 0.8 and the ice which is 0.5. This is the specific heat give to the substance. Temperature scale. Two commonly used scale for measuring temperatures are the Fahrenheit scale and the Celsius scale. There are temperature scales, Fahrenheit scale and Celsius scale to identify of the any type of the heat scale. On the Celsius scale, water freezing point is 0 degree centigrade and boiling point is the 100 degree centigrade. Celsius scale is a freezing point which is the 0 degree centigrade and boiling point which is the 100 degree centigrade. The interval between two fixed points is divided into 100 equal parts. Means the interval between two fixed points is divided into 100 equal parts, which is divided by the 100 equal parts. This is the some formulated factor we are appearing here. This is the interval between two fixed point in divided 1 by 100 equal parts. 1 Fahrenheit scale, the freezing point of the water which is 32 degrees centigrade and the boiling point of water which is 12 degrees centigrade. Means ki the Fahrenheit scale, the freezing point of the water which is the 32 degrees centigrade and the boiling point of the water which is the 12 degrees centigrade into the Fahrenheit. The interval between two fixed points divided into 180 equal parts. How much amount? 180 equal parts, which is divided by these parts. Next one. Here some boiling point in a Fahrenheit and into the Celsius. The boiling water into the Fahrenheit which is 212 Fahrenheit and into the Celsius which is 100 degrees centigrade as according to the temperature of the water. Freezing point which is the in a Fahrenheit which is 32 degree Fahrenheit and into the Celsius which is the 0 degree centigrade. Now the clinical thermometer. This thermometer which is used to record the temperature of the body, the thermometer which are used as to record for the temperature of the body, and it may be measured in a degree Fahrenheit or degree Celsius. It may be measured in the degree into the Fahrenheit or in the Celsius, which is the clinical thermometer and the temperature portions which are used. Parts of the clinical thermometer. Means ki what are the parts of the clinical thermometers here? See, this is the bulb which are going to be enter into our mouth, underarms, right? See, these are the measurement of the bulb. We have to put it down into the under the tongue into the mouth. This is the mercury which gives to rise as according to the temperature which is going to be rise, as according to the temperature which is going to be freezing, which is move forward and the backward. This is the capillary tube vein which is passed this mercury as according to the temperature. This is the stem and this is the thermometer. Next one. The stem of the thermometer usually has a curved surface that magnifies the numbers on the scale and a flat surface that prevents it from rolling. A white backing is made behind the mercury column to make reading easier. The mercury column which is make reading very easier. The bulb of the oral thermometer is usually long and slender. Due to this, mercury in the bulb is exposed to the larger surface. Means ki the bulb of the oral thermometer which is usually very long and slender, means ki a slender like rod shape, and due to mercury which is passed into the bulb to the capillary factor as according to the temperature which are going to be higher or temperature which is going to be lower, as according to which is move exposed to the larger surface. The mercury absorbs the heat rapidly and registers quickly a maximum reading. Mercury which is absorbed heat very rapidly and register which is very quickly at a maximum reading. Next one. A rectal thermometers have shorter, thicker, walled bulb and register more slowly than oral thermometers. A rectal thermometers which is have shorter, thicker and a walled bulb and registered more slowly than to the oral thermometer, which is going to be very slow than to the oral thermometer, clinical thermometer. Before using it again, it is raised by shaking the mercury down into the bulb. Whenever you are using a thermometer, patient by patient, you have to clarify that things. A bulb of the mercury which is going to be settled, means at the zero. Then and then you can apply into another patient. Next one. Regulations of the body temperature. Now we are talking about the general heat to using in a nursing. So what the type of the heat process, the types, measurements, regulations, conversations, kinetic factor we have to study. How to be correlate of this heat factor with our biological mechanism in our human being. This is the regulation of the body temperature. So like basal metabolism of the body causes heat production, means ki our basic metabolism of the body which is causes heat production. Metabolism process always give the release of the heat. In order to maintain a normal body temperature, there must be mechanisms of heat transfer so that the heat loss balances at the heat gain. Means ki which is going to be balancing factor, heat loss, balance and gain. The main heat loss mechanisms are conduction, convection, radiation and evaporation. The main heat loss mechanisms which are conduction, convection, radiation and the evaporation. Let's talk about in a detail. When the body temperature which is going to be rise, whenever the body's temperature which is going to be rise, means it is going to be increase, the hypothalamus, this is the gland of the hypothalamus, a major gland of the all glands, which is the major gland which control to other all glands in our body. Hypothalamus initiate, means started sweating and vasodilation, which is started by the sweating and the vasodilations by the hypothalamus gland secretion. This is the messenger passed by some enzyme mechanism. When body temperature drops, hypothalamus initiates shivering, which tends to restore body temperature. When the body's temperature is going to be less, hypothalamus initiates by the shivering means ki shivering hona, which tends to restore body's temperature, which is going to restore again, which is lost the temperature up to the zero, nearby the zero, which is called as the freezing factor. But our body is not going to be freezing, otherwise no one can be live in this earth at the 0 degree centigrade. We have to maintain some temperature. So we are going to be warm up, and our blood which is going to be warm, and metabolism process and living process is there. Heat productions per day in human body is 120. This is the factor 120 water for the maintaining of the body temperature, and heat should not lost from body at the same rate. Means ki maintaining by the body's temperature heat which should be lost by the body at the same rate. Human body employs more than one of the mechanism to transfer heat to the surrounding. Means ki human body which is employed more than one of the mechanism which is going to be transfer heat by the surroundings, which is transferred by the heat by the surroundings. Example, therapeutic effect of the solid sponging for high fever patient, which is achieved due to transfer of heat, conduction, convection and evaporation. Means ki therapeutic effect, which is a therapeutic factor, which effectivity which is effect onto the cold sponging for high heat patient. If the high heat patients we are taken a cold sponging effect, the temperature which is losses down. So this is achieved for the heat by the conduction, convection and evaporation. Okay. The cold sponge placed over groins, axilla, neck, forehead. The patient takes heat of the circulating blood and brings down the fever to the safer range. The cold sponge placed over the groins, axilla, neck and forehead. The patients which are, this is the portion, the patients which is takes the heat of the circulating blood and bring down fever to the safer range. Skin of the whole body also loses heat by conduction, convection and evaporation. Means ki the whole body skin which is losses heat by conduction, convection and evaporation. The temperature of the human body is the result of the balance between heat energy produces and heat energy lost. Means ki the temperature of the human body which is the result of a balance between the heat energy and which produce the heat energy produced and lost. Heat which is produced due to oxidations of the food and lost from the body by conduction, convection, radiation and evaporation. Means ki which is produced by the oxidation of the food, means ki in the presence of the oxygen, and the lost by the from the body by the conduction. This is the mechanism, convection, radiation and the evaporation factor. Next one. Most of the heat of the body is lost through by the skin. Means ki most of the heat our body which is released by the skin. The rate at which heat lost from skin which depends on the temperature difference between the skin and the environment. Means ki which is different by the environmental surrounding environment, which is depends on the temperature difference between skin and the environment. What the type of the environment which are exposed by our skin, our human body skin, depend on to this factor. Half of the heat produced in a person which is lost by simply sitting in a room at 22 degree centigrade. Means ki half of the heat which is produced in a person lost by simply sitting into the room at the 22 degree centigrade. The heat losses at room temperature which is significant. Means ki the heat which is lost at the room temperature which is significant, which are going to be significant. Death of a person with heat or sunstroke happens, sunburn, sunstroke, because external heat applied to the body exceed the amount normally lost. Means ki death of the person with heat or sunstroke. Sunstroke means ki sunburns factor, which happens because the external heat applied to the body which is exceed the amount normally lost. Now another utilizations of the heat, the use of the heat for the sterilization. This is the sterilization heat used. Sterilizers are based on the Charles law. What is the Charles law? The temperature of the gas increases as the pressure increases when the volume which is kept constant. Means increase as the pressure when the volume which is kept constant. The increase the temperature of the gas resulting from increase the pressure and destroy the microorganism. The increase the temperature of the gas which are result from increase the pressure and destroy the microorganism. As according to the temperature which are going to be rise and the pressure which is going to be rise, the microorganisms which are going to be destroyed. Non-spore forming bacteria which are killed at the 52 degree centigrade to 70 degree centigrade. Means ki non-spore which is very hazardous. Spore formations which is always resisted at the higher temperature which is the 120 degree below temperature, and the sterilizer's temperature, the spore forming bacteria which are always which will be destroyed at the 121 degree centigrade. The boiling water which is sufficient to kill them. The boiling water which is sufficient, but which type of the bacteria? Which are only the non-spore forming bacteria which are killed by this temperature. Now we are talking about the spore forming bacteria. So first of all, I hope you are understand well into microbiology. A spore forming bacteria. What are the spore forming bacteria? Which is registered at the higher temperature, that is 120 degrees centigrade. Due to of that reasons, the sterilizer's temperature, the autoclave's temperature, which is maintained at the 121 degrees centigrade due to of the spore forming bacteria. The spore forming bacteria requires temperature from 72 degrees centigrade to 110 degrees centigrade. Hence, 120 degrees centigrade for the 30 minutes is the ideal temperature for the actual sterilization, which is the ideal temperature for the sterilizations of the spore forming bacteria, because always spore forming bacteria which is killed at the 121 degree centigrade. Sterilizers that are used for sterilizing glass, wares and the powders are based on the dry heat. Dry heat which temperature which is 160 degrees centigrade, which effective to kill the bacteria. Sterilizers that are used for sterilizing the glass, wares and the powders which are based on dry heat, which are based on to the dry heat by heat with the temperature with a 160 degrees centigrade, effectiveness to kill the bacteria. Here I am taking some peek of the autoclave. This is the pressure regulating device. This is the pressure gauzes. This is safety valves. This is autoclave lid. Here this is the handles, body, steam, then after vacuum, release and the outer stand. This is the overview of the all nomenclature of the autoclave, how it's work. Autoclave is equipment used for sterilizations of surgical tools and items required for sterilized process. Means autoclave is the equipment used for the sterilizations, which are used for the sterilization. Obviously, autoclave, one line's answer, a steam under pressure. Steam under pressure. Pressure is 15 lbs and the temperature which is 121 degrees centigrade and which is capable for destroying the spore forming bacteria. Autoclave is a device which contains steam in a closed chamber of constant volume and temperature of the steam which is increased. The temperature of steam rises to 125 degrees centigrade due to increase the pressure. So which is steam which is going to be rise at the 125 degrees centigrade due to increase the pressure. Due to such high temperature of the steam, microorganisms present in the tools kept in autoclave are destroyed. Means ki such high temperature of the steam, microorganisms present in the tool which is kept by the autoclave and destroy. Means what is that sentence mean? High temperature means ki 121 degrees centigrade and the microorganism present which is gives to keep autoclaving which are gives to destroy the microorganism. Now what is the applications of heat principle in nursing? Let's see the use of the heat and the cold applications in the healthcare practices to manage several type of the disorders, which practices by the several types of the disorders by accurate measurements of the body temperature and working of the clinical thermometer, which is working with the clinical thermometer, means ki which gives to the heat and the cold by the thermometer factor, clinical factor, temperature scales and conversions of one type of temperature scale in another like centigrade of Fahrenheit scale or vice versa. Means temperature scale conversion Fahrenheit to the Celsius. Celsius which is we are taking about that 100 degrees centigrade and 0 degrees centigrade, this is the Celsius. And this is the conversions by the measurement factor which are used to identify some measurement of the temperature. Next one, transfer of the heat from body to surrounding or vice versa. To understand about the regulations of the body temperature by losing the heat by different means like conduction, convection, radiation and evaporation. Means ki we have to understand about the regulation of the body's temperature by losing that heat by the different means like conduction, convection, radiation and evaporation. Use of the heat in sterilizations for destructions of the microorganism. The heat into the sterilizations of the destructions of the microorganism means ki kill.